I totaled my car.
All right, so we're gonna talk about projectile. So if I would have okay, so if I were to talk about average velocity, so let's start talking about average velocity. So we start with average velocity. Okay, average velocity is basically the changing of distance. So change, we're going to use delta of distance over changing of time. Okay, so changing distance over the changing time. But if usually we're going to use the function s for position function. So usually it says s of b minus s of a over b minus a. We have different s stand for precision functions. Okay, so s of b minus s of a over b minus a. Yes, that does look familiar. That should be your slope of the line equation. So if you take the slope, it's going to be your average velocity. Okay, are we okay here? Okay. Now we're going to talk about instantaneous. We're going to talk about average versus instantaneous. So instantaneous. How to spell instantaneous?
Just put a dot. Put a dot.
Velocity. That stands for instantaneous velocity. That's equal to v of t or s prime of t. And we're going to talk about that. It's taking derivative. That's how you take a laser gun and you shoot and you see how fast a person running. Just like a steel frame, how fast Yuzochi is running versus Mr. Ye. So I actually take that video is because for this class to actually kind of get people to think about speed. So instantaneous velocity is equal to v of t or s prime of t. But the way to best judge velocity is start from introduction. So it's like I'm coming forward, I'm driving backwards. We're going to talk about that. But the best thing to talk about is actually in physics. In physics, what do we talk about? Projectile. If you ever watch the movie says travel to center journey of the center of the earth. So that movie, he had to drop a I think glowing stick or something, and count how long 1, 2, 3, 4, 5, 6, and you say, oh yeah, it's roughly how many feet. But technically, they're coming from projectile functions. How do we know how many feet it dropped? So it turns out there was a projectile equation, and projectile equation in physics that we learned is this one, as s of t, and this is not the first time you've seen this, by the way. This is probably the third time. So s of t is equal to 1/2 g of t squared, okay, plus v0t plus s0. Okay, so g in physics, we're gonna say is g is what? G is what? Yeah, what is a? Is a 9.8 meter per second square. So it's not the same as a velocity. It's not the same as a velocity, but it's gravity, which is that's an acceleration. Okay, so let's talk about there's a difference between velocity and acceleration. Now, but unfortunately, we are in the United States. We're not as advanced, so we don't use matrix system. So we are actually a little bit backwards. So we use this one's negative, and we use a negative 32 feet per second squared. That's how we deal with when we deal with calculus. In physics, we're going to use negative 9.8 meter per second squared. In calculus, we use 32 feet per second squared. I don't know why they still stay with 32 feet per second. I think it's an integer, so it's easy to take integral and stuff like that. So you say, okay, that's very easy. So what is s of t? S of t is equal to position at given time. So we call this as a projectile function. Sorry. Now in physics, you might deal with two dimensions. So you might deal with sine and cosine. There's x component and there's y component. So here we only strictly deal with the y component of the pictures. So now we're gonna say S of t is position at given time. So then you say, okay, well, what's everything else? Well, what is g? G is the acceleration, which is right here. It's 9.8 meters per second squared. And what is v0? V0 is called, anything with a zero is called initial velocity. Initial velocity. Okay. Anything that S0, guess what? That's initial positions. So at very beginning, which position I'm at. Okay, so initial position. So we can also talk about v of t, which is instantaneous velocity, but we're going to talk about relationship between position, velocity, and acceleration. So this is S of t, that's called positions at given time. But if you have v of t, that means equal to, take a derivative of S of t is going to be S prime t, the same thing as v of t. Or a of t, which is acceleration, that's equal to v prime of t, or s double prime of t. That means I take a derivative of position function twice, I'm going to get acceleration. Or I'm taking derivative of velocity once, I'm going to get acceleration. So the order is actually svt. So when I'm going down, that means every time I'm going down, I'm taking derivative. So this is a derivative. So this is a derivative. But if I'm going up, later on we're going to learn that's called integrations. We can actually integrate from acceleration to velocity function, from velocity to position functions. Okay. Any questions so far?
Is it T or is it
It's SVA. Thank you. Okay, so think about what I'm saying. So if I going up, it's going to be integrations. So that's the integration from here to here. So going down is always derivative. So it's SVA, that's what happened. So that's the basic things about projectile functions. And you say, okay, so how do I really apply to real life? How do I know if I drop the thing there and I say how long does it travel? So we're going to talk about that. Can you erase this part? Okay. So we're going to pretend that there is a man that is doing the Olympic diving into the water. And she's gonna do is gonna jump, 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 and she's gonna jump, or he's gonna jump, and it's gonna be a triple axel, and poof, right, and go into the water. So what happened is we're gonna pretend that's me. I'm gonna jumping, okay. So I'm not gonna be very good drawing of what happened. So we're gonna say this platform is 32 feet. And this is a platform, and this is a me. It's impossible to jump down unless you're on the upside of the springboard and you push down. It's really hard to jump down. You always jump up and come down, right? So that's how you go and have some type of initial velocity. Now let me stress something. Velocity has a direction. Speed has no direction. So we're going to talk about that later too. We're going to say speed is equal to absolute value of velocity. It's always positive. But if you talk about velocity, has a positive or negative. So you can technically, you can throw down a penny from that 32 feet per second. You can throw it down, your initial velocity could be negative. But usually if you jump up, right, this man is jumping up, and boop, come down, and there's the water here, and then boop, or when you got sick of IB, no, I'm just kidding. So then we're also going to talk about this man isn't jumping in a certain speed. The speed is he's going to jump up. Okay, so it's going up. So it has a positive velocity. So we're going to say that initial velocity is equal to 16 feet per second. 16 feet per second. And at a 32 feet, so S0 is equal to 32 feet. Okay. So we want to understand a couple things. We want to understand, so when the diver hit the water, so we're going to say A, we're going to find out when is the diver hit the water. Okay, so that should be pretty easy, but that's okay. We're gonna figure out that. B, we says when the diver reach maximum height. So obviously he's gonna jump out and then come down. So how long does it take? When is the diver reach maximum height?
So the initial velocity would be given. We don't have to calculate it.
No, AI is given to you. Okay. And C is, wait, that's when the reach maximum height. And C is what is maximum height? What is the maximum height? Okay, I can even say for D, we're going to say what is the impact speed? Velocity when it hit water. Okay? And find the average speed between, so E, we're going to say find average speed. Average velocity.
Good afternoon, Cypress Creek Bears. A couple of afternoon announcements.
Wait, my time's up.
Today, first, Cypress Creek High School basketball boys will have an interest meeting.
But they're gonna waste the 5 minutes with this.
Tomorrow,
Yeah.
September 21st, right after school. That'll be Friday, right after school in the PE classroom.
So meanwhile, just copy down the stuff.
Basketball for the Cypress Creek Bears. Please meet right after school tomorrow, September 21st, in the PE
D says what is impact velocity? What is impact velocity when it hit the water? So how fast, when I hit the water, how fast I'm going?
That's what we like to hear.
Okay.
But if you did not receive an appointment card, you need to go to room 5107 to pick one up again. If you did not receive an appointment card for the blood drive tomorrow, go to room 5107, see Ms. Velasquez, and she'll help you out with a appointment.
So,
And then finally, make sure that you're here tomorrow for our football game as varsity takes on the West Orange Warriors. So again, stay safe, and we'll see you tomorrow.
because some of you guys think about what would be the SAT is. For SAT, we already have all the information. If you pay attention, have, right? What is G? 1932, right? So we're gonna say 1932, and the T squared plus what's the initial velocity? Zero. No. 16. And then plus S0 is what?
32.
What is jumping now?
Wait, why is S0 32 feet per second?
Because
I think you wrote it wrong.
your units.
Don't worry about it.
It's just initial
Don't worry about it.
speed.
Oh, does it too? Okay. So I already write this. S of t is equal to negative 16t squared plus 16t plus 32. So if I want to find out what happened at 1 second, how high I am, I'm gonna plug in 1 into here, and then that's gonna give you 32 feet. In 1 second, I'll reach the 32 feet. Does that make sense? I just plug in the t is equal to 1, then I'll find out what's my height when I'm 1 second out. Am I going too fast? No. Okay, so now let's talk about when is a diver hit the water? At 1 second. At first we said S1 is what happened. What's my height at 1 second? So when is a diver hit the water? What do you suggest? How do I do it? Find the x-intercept. Good, but there's no x-intercept. There's t right here, and there's s of t. So what would it be?
The t-intercepts.
Not t-intercept. What is equal to 0? S of t equal to 0, right?
Why is it 1?
Because S of t represents height at given time, but if we say that's 0, so we're going to say A that's equal to 0 equal to negative 16t squared plus 16t plus 32. And I can factor out negative 16. I'm going to get t squared plus minus t plus 2. And I'm going to factor it, that's equal to, I'm going to divide by 16 on both sides, so I'm going to be t minus
Yeah, isn't it
2
minus
and t plus 1.
I mean, like, the step above, isn't it t squared minus t minus 2?
This is negative, right?
Yeah.
So that's equal to t equal to 2, t equal to negative 1. But time can never be negative, so it's just 2. So it takes 2 seconds to hit this part. So t is equal to 2 right here when they hit the water. Are we going? I'm going too fast?
One more minute.
One more
You gotta go
minute.
faster, Mr. A.
Okay, when is a diver reach maximum height? So if you have to go, I understand, but just give me 5 minutes to finish if you can. When is the diver reach maximum height? So if I'm jumping, right? If I'm jumping to the highest point, what will happen? Now the maximum height is like a vertex we talked about yesterday, which is what? Not negative equal to 8, but what?
Derivative equals 0.
Derivative is equal to 0. So velocity is equal to 0. So this one means the velocity is equal to 0, because if I were to throw a marker high up, at one point the gravity is keep on pulling down, but your initial velocity is the gravity is gonna eat your initial velocity until it get to 0. If you take a still frame picture, that you see the picture that is gonna be a scatter of the marker, and going up here is gonna be the highest points. And then it's gonna come back down. I will finish recording this video, don't worry. So if you have to go, I understand, but if you want to finish listening, that's fine. V of t is equal to 0. So can I take a derivative of this function?
Natasha, when are you leaving? When are you leaving? When are you leaving? Nah, I didn't take the bus.
Okay? And now set that equal to 0. So 0 equal to negative 32p plus 16. T is equal to 1/2. So t equal to 1/2. And I'm going to go to see when is the maximum height. Well, if I want to find out the maximum height, what do I take the 1/2 plug into? If I want to find out how high is it, what do I plug into? The original, right? Yeah. So S is a 1/2. That's equal to negative 16 times 1/2 square plus 16 times 1/2 plus 32. So that's equal to 1/2 times 1/2 is going to be what? 1/4. So it's going to be negative 4 plus 8 plus 32. That's equal to 36 feet. I think.
Okay. Let's walk it back. Can we
Okay, go ahead.
Yeah, I don't.
The 1/2 thing, you want to restate what you said?
Okay, so they say what is the maximum height? But we already know when do they reach maximum height. So if I find out t is equal to 1/2, right? T is equal to 1/2. So I can plug in 1/2 into the position function to find out how high is it. So I can plug in, so if I do my math right, hopefully I do. 4, negative 4, 8, 32 feet.
Wait. Oh, sorry.
So for B, you just take the derivative and then solve for T.
Take a derivative, set the real velocity is equal to 0.
Okay.
Okay? So now we're gonna go with D. D says, what is impact velocity? Well, impact velocity happen when? When what? T equal to 2. But what do I plug in 2 into? The velocity equation, which is right here, right?
Wow.
So we can plug in this one. We can say, hey, let's plug in V of T.
Okay.
Let's say V of 2, I can find out the speed of 2, so it'll be negative 32 times 2 plus 16. So that's equal to negative 64 plus 16. Now you had to including the units, so it's equal to negative 48 feet per second. So that's D.
Let's say negative 52. 32.
Yeah, negative 32 is right here. Negative 32 T plus 16. That was my derivative when I take a derivative, right? So from here to here, that's derivative. Now last part, I'm sorry to take you this long. I shouldn't show you the video, but I thought it was funny. So this one I can measure the precision. So I can use that formula I give it to you. The average velocity equation is what? S of what? B minus S of A over B minus A, right? So that's just S of 2 minus S of 1 over 2 minus 1. So if I plug in 2, what am I going to get? If I have 2, I'm going to get 0, because we already know it's 0. If I plug in 1, what am I going to get? 32. So over 2 minus 1, so it'll be 1, so it's equal to negative 32 feet per second. And then that's it to finish. So today you can try to look at how do you think about all those things. Think about what's your initial velocity, think about all those things. So if you go in through, you should be able to solve some problem. We're going to give you one example for today. I'm going to go back to ask you how to do a K problem and stuff like that. Okay?
So we're only gonna have one problem on this for homework?
Yeah, I think the 1 is good. I'd rather you do 1 and understand every parts of it.
Wait, so this is gonna be on the test?
Yes, it's going to be on a test, but it's not going to happen the
No,
next
we're
week.
just doing this for fun, Maya. For fun.
Any questions?
Are you gonna erase it?
No, I'm not going to erase it for now. But there's also video on it.
So yeah, why can't you teach physics?
Huh?
Why can't you teach physics?
I want to. I wanted to teach physics, but I'm not good enough yet. But I think I need 1 more year to practice.
Have you watched The Office? Mr. Yeah, you're better than Mr. Trip.